Today we are going to learn basic concepts of OOP, that is object-oriented programming. Basic concepts are classes, objects, data abstraction and encapsulation, inheritance, polymorphism, dynamic binding, and message passing. Let's see one by one in detail. First, we are going to learn what is a class. A class is a collection of objects of similar type. Just imagine a class. That is, suppose you are studying in standard 1. Okay, you are studying in standard 1. So what is, that is the members of that particular standard are the students who are studying in that class, right? Suppose you are studying in some other higher classes. Suppose you are studying in engineering. So in that particular class, in that particular section or class, the contents or the data are the objects, students who all in that particular class. No other class student will come and sit in that particular class, right? So that is what a class is, a collection of objects of similar type. A class in C++ is a user-defined data type or data structure declared by the keyword class that has data and functions as its members, whose access is governed by three access specifiers: private, protected, and public. That is, a class is a user-defined data type. That is, my class is being built or being prepared for based on the user's interest. So that is why user-defined data type. And the keyword used is class. And within that class, data can be there and functions can be there. They are the members of that particular class. And the access, that is how the data and the functions written within the class are to be accessed, is governed by three access specifiers: private, protected, or public. That is what. That is access, how that particular data and functions can be accessed to the public. They can be, we all of us are using Facebook, right? So when you are putting a photo or when you are uploading a photo, you can make it as private, you can make it as public, you can make it as logged, etc. The same way, the data and functions within the members, that are the members, right? So that data and functions can be accessed based on three access specifiers. If you are making it as private, some categories are there. If it is protected, some other. If it is public, some other. That we'll study in detail in the next class. Okay. So by default, access to members of a C++ class is private. If you are not giving any access specification, it becomes private. Okay, that is, it is a class is a collection of objects of similar type and is a user-defined data type used by the denoted by the keyword class, and the members are data functions, data and functions. That is data members and member functions. And access can be private, protected, or public. Normally, by default, the access is private. Next is objects. In the last slide, we have seen class includes objects, right? So objects are the students in the particular class. Okay, so that is what are basic runtime entities in an object-oriented system. Runtime entities, that is when the program is being executed, at that time objects are needed. Objects are instances of class which holds the data variables declared in class, and the member functions work on these class objects. Always the member functions or the data members worked on the class objects. Each objects have different data variables. Objects have different data variables. An object is an element of a class. That is, Class includes objects. So objects have the behaviors of their class. So when a particular student is in first year engineering class means, or first some particular class means, that whatever the features are there for that particular class, the same features are there for that students. Okay, so that is objects. So here's an example of class and object. Mango is there, apple, banana. We know that all of them are fruits. So you can write class is fruit. Okay, and mango is a data. That is, mango is a fruit and it belongs to the group fruit. Okay, so this will create an object mango. Mango is object and class is fruit. Hope that class and object is clear for you now. That is, this is the standard name fruit. Here you can write this class name and here you can write the object within that. So within this object only the class will be executed. Next is data abstraction and encapsulation. What is abstraction? Hiding unwanted information. That is abstraction. That is the main characteristics or concept of OOP is data hiding technique. So that hiding that particular method is known as abstraction. Is a method of hiding the unwanted information. That is that need not made to be public. So it is kept as hidden. That is what abstraction. Hiding internal details and showing functionality only. Suppose just consider a television. So what is there? You just see the screen, right? You are just that the screen is only open to us. We don't know what is the internal circuit, what are the transistors or what are the capacitors, what are the internal circuits. We don't bother about that. We just see the screen. So the internal details have been hidden and we are just seeing the functionality. That is hiding internal details and showing functionality only. Next is focuses on what the object does instead of how it does. Focuses on what the object does. That is, we just want to see whether it is whether the television displays the picture in a right manner or not. We don't want to know what is happening inside. That is data abstraction. Again, it is being explained, wrapping code and data together into a single unit. Class is an example of encapsulation. The next one is encapsulation, data abstraction and encapsulation. Okay. So what is, just remember, a medicinal capsule. So you know that within that capsule, many granules will be there. We don't know what are the granules and we don't open it and see what is inside, right? So that hidden portions are being wrapped in one cover and that becomes a capsule. Same way, class is an example of encapsulation because it wraps the method and property. Within the class, methods and properties will be there. Encapsulation is a process of combining data members and functions in a single unit called class. This is to prevent the access to the data directly. The access to them is provided through the functions of the class. That is, through the functions of the class that data are being accessed. It is one of the popular feature of OOP that helps in data hiding. That is what data hiding. That is one of the important feature of OOP. And that is what data abstraction and encapsulation says. Next is inheritance. Inheritance is an important concept of object-oriented programming. Inheritance allows us to define a class in terms of another class, which makes it easier to create and maintain an application. This also provides an opportunity to reuse the code functionality and fast implementation time. Here the feature is reusing feature. Okay. Just consider we are having the features of our parents, our grandparents and so on. When someone takes the features of us, naturally the features of our parents or grandparents can also be accessed. That is, in us, within the features of, within our features, our parents or our family features will also be enclosed. That is what inheritance. That is when we call a particular child feature naturally or automatically as hidden, his parents' feature also will come. That is what inheritance. That is what here it is written. Inheritance allows us to define a class in terms of another class. That is, a parent can be called, or feature of the parent can be called with the help of feature of the child. That is what inheritance allows us to define a class in terms of another class. With the help of a class, you can call another class also. And that is reusing capacity. And that is another important concept of OOP. Again, it is written, when creating a class, instead of writing completely new data members and member functions, the programmer can designate that a new class should inherit the members of an existing class. That is, inherit, includes. This existing class is called as a base class, and the new class is known as the derived class. That is, the parent class is known as the base class and the child class is known as the derived class. Idea of inheritance implements the is a relationship. That is, mammal is a animal. Animal is the parent class and mammal is the child class. So you can say mammal is a animal, is a relationship. Dog is a mammal. Again come see, dog is again the child and mammal is the parent. So mammal is a child of animal, right? Mammal is an animal. So you can say whatever the features of that animal, it comes in mammal. And here dog is a mammal. So feature of mammal will come as a feature of dog. That is a chain and that is reusing. So here is an example of inheritance. That is, vehicle is the base class. Two classes have been derived from vehicles. They are the motor vehicles and pulled vehicles. These vehicles are divided into two. Motor vehicles are there, pulled vehicles are there. Again, for motor vehicles, car is there, bus is there. Here carts are there and rickshaw is there. So we know that vehicles will be having its own attributes, its own features. When it is divided into motor vehicles and pulled vehicles, motor vehicles are having its own feature along with the features of the vehicle. Same for pulled vehicles, they are having its own feature that is pulled by something and it is having the features of vehicles also. Same, car is there, bus is there. Both are, we know both are motor vehicles. That is, both of them are having the features of motor vehicles and they are having their own features. Okay, this is inheritance. Here the parent class or this is the base class and these are the derived classes. When you come to this, vehicle is the base class and these following are the derived classes. So when you come to car class, when you come to the derived class, automatically the base class are also being used. This is inheritance. Next is polymorphism. What is morphism? Changing the shape. Polymorphism, changing the shape into many. That is polymorphism. That is what? Many forms. When you are taking plus, this is a sign what you are normally doing for addition. Same can be used for when it is being used with plus plus. See, the concept have been changed. It is auto increment. And when it is used in a particular word, that is my is there and then plus self is there. That is my plus self. What will be the answer? The answer will be myself. Right? Here plus is acting as concatenation. See the difference? That is plus is having different uses now. So that is what polymorphism means, many forms, and it occurs when we have many classes that are related to each other by inheritance. C++ polymorphism means that a call to a member function will cause a different function to be executed depending on the type of object that invokes the function. Based on the type of the object, the functionality keeps on changing. That is polymorphism. Consider the operation of addition. For two numbers, the operation will generate a sum. If the two operands are strings, then the operation produces a third string by concatenation. Same plus addition. Okay, so same addition is having different features. When it is used for sum, it will add, and when it is used with strings, it will go for concatenation. That is polymorphism. The process of making an operator to show different behavior in different instances is known as operator overloading. And another one is function overloading. When the operator is keeping on changing the features, that is operator overloading. And when the function is keeping on changing the feature, that is function overloading. Here, function overloading example is given over here. Shape draw. This is a function. Draw is a function. You can draw triangle, you can draw circle, you can draw a square. Okay. So the same draw function, just change the attributes, values. You can draw the circle, you can draw a triangle, or you can draw a square. This is function overloading. Next is dynamic binding or late binding. Binding, what is binding? That is including or adding. Binding refers to the linking of a procedure call to the code to be executed in response to the call. That is linking of a procedure call to the code to be executed in response to the call. That is based on the call, based on any particular call, the code and the procedure are being connected or being binded. That is mixing, adding, that is binding. Dynamic binding means that the code associated with a given procedure call is not known until the time of the call at runtime. That is at the runtime only. Runtime is the last time, last case, that is execution time. During that time only, the code associated with a given procedure call is known. Other than that, it is not known. That is dynamic binding or late binding. Late, that is at the end only we are going for execution. That is late. And at that time only it is binding. The code and the procedure are being mixed up. That is, the code and procedure call are linked only at run time. This sentence is explained more clearly with this. The code and the procedure call are linked or connected or added only at the runtime. Runtime is a late time. Okay, think like that. So that is why it is known as late binding. It's message passing. Whenever we do anything, message is being passed between them. That is, objects communicate with each other by passing messages. Message passing specifies the name of the object, function, and information to be sent. These messages are passed between object, function, right? So that is message passing. So contents will be from where? to where and what is to be passed. That is message passing. In today's class, we have gone through the basic concepts of object-oriented programming. Classes were there: classes, objects, data abstraction and encapsulation, inheritance, polymorphism, dynamic binding, and message passing. These are the important characteristics of object-oriented programming, and based on these only, procedure-oriented programming and object-oriented programming have been differentiated. These are the differences between them. Okay, these are the important concepts of object-oriented programming, and we'll see, we have to study in more detail in the next classes. Hope this is clear for you. Thank you.